Hey BC, welcome to day 2 of digital learning. So hopefully you're able to print off a copy of these notes. If not, that's okay. Grab yourself a piece of notebook paper. And here's what I want you to do. I want you to, without looking at any previous notes, jot down the answers to these first 6 boxes. So if you were not able to print it out, I'll read through them real quick and jot these down on your notebook paper. I want you to write down the general term for a Taylor series centered at x equals c. Write down the general term for Maclaurin series. Write out the first 4 non-zero terms and the general term of the Maclaurin series for sine x. Same thing for cosine x, e to the x, and then 1 over x. So go ahead and pause this video, jot all those down from memory. Okay, so hopefully you're able to do the first 6 boxes from memory correctly. Let's go ahead and write them down real quick. The general term of the Taylor series is the nth derivative of f evaluated at c, x minus c to the n, all over n factorial. The general term of the Maclaurin series is the nth derivative of f evaluated at 0, x to the n over n factorial. Okay, so sine x. Remember, sine is an odd function, so its Maclaurin series is the odd powers of x. Make sure that it's alternating. Don't forget any factorials. Make sure you do a dot, dot, dot. And then we're going to go all the way to the general term, which is negative 1 to the n, x to the 2n plus 1 over 2n plus 1 in parentheses factorial, do another plus sign and a dot, dot, dot. Cosine is the even function. X to the 2n and the 2n in parentheses factorial, and then a dot, dot, dot. Okay, the first 4 non-zero terms in the general term of the Maclaurin series for e to the x. So that one is 1 plus x over 1 factorial plus x squared over 2 factorial. You can write 2 factorial or you can just write 2 plus x cubed over 3 factorial. The general term is x to the n over n factorial. And 1 over 1 minus x, this is just the really super easy and straightforward one. This is just 1 plus x squared plus x cubed. And the general term is x to the n. Let me see if I can move this. I am making this video with my laptop facing down because I don't have enough storage left on my phone to capture this video. So it's a little bit tricky. Okay. I think we're good. I think we can see the rest of those problems. Okay, so the function f is twice differentiable with f of 2 equals 4, f prime of 2 equals negative 6, and f double prime of 2 equals 9. Write the second degree Taylor polynomial for f about x equals 2. Use the Taylor polynomial to approximate f of 2.2. So what I like to start out when I do these problems is just to help myself remember what each term of the Taylor series looks like. I just like to write them out in symbols first. The 0th derivative of f evaluated at 2, because that's where our center is, x minus 2 to the 0 power over 0 factorial. So I'm going to do that for the first 3 terms. F prime, so I'm replacing all these zeros with a 1. So basically 1 prime, x minus 2 to the 1, and then 1 factorial. And then everywhere we had a 1 here, these 3 places, we're going to replace it with a 2, or a double prime. F double prime of 2, x minus 2 squared over 2 factorial. Great. Now we're just going to go ahead and input these values that they gave us. So the f of 2 is 4. I don't need to write anything else because anything that is 0 power is just 1, 0 factorial is just 1, so that goes away. And then we have f prime of 2 is negative 6. X minus 2 to the first power over 1 factorial. And then we have 9, because that's f double prime of 2, x minus 2 squared over 2 factorial. You can write 2 factorial or just 2, it doesn't matter. You could simplify this to 4.5 if you wished. So this is not equal to f of x, it's an approximation of f of x, but what we usually call this is like something like t sub 2 of x. The 2 means it's the second degree, because that's the largest exponent, second degree Taylor polynomial. And then to find f of an approximation of f of 2.2, we're just going to go into this polynomial that we created and replace all of the x's with 2.2. No simplifying necessary. All right, pretty easy, right? All right. Okay, down at the bottom. The third degree Taylor polynomial for a function f of x centered at x equals 5 is given by this. What is f double prime of 5? Well, to find f double prime, we're going to have to look at this term. And what I like to do is I like to write the general form of that term and set it equal to this. So here's what I mean by that. This term is determined by f double prime of 5, x minus 5 squared over 2 factorial. So just like I'm using that's what we wrote in the very first box on these notes and rewriting it where n equals 2. So we're going to go here and set that equal to this term. So x minus 5 squared over 12. So I can just divide this out of both sides, and then to find my f double prime of 5, I'm just going to take this 2 factorial, which is just 2, and move it to the numerator on the other side. So 2 12, so 1/6. Okay, what is f of 5? Well, that's just this first value here. It's 8. Okay, these last two are super easy. We just want to see which of our 4 Maclaurin series that we have memorized this resembles more closely. So this looks a lot like cosine x, except in place of x, there's been a 4 inputted. So this series is just equal to cosine of 4. Actually, this is how your calculator evaluates trig values. It does not know how to use the unit circle and find cosine of 4. It approximates cosine of 4 by using the first several terms of the Maclaurin series for cosine. This one, it resembles e to the x, and in place of all the x's, there's been a 3 inputted. So this is just equivalent to e cubed. Okay, go ahead and try that homework that's related to this. I'll post answer key to that tomorrow. And if you can't print it out, that's okay. Just try the problems on notebook paper. Invest in yourself. Stay healthy. Stay home. Do calculus. It's really good for your health. And know that I care about you guys and I miss you a ton.